Now, let us consider capacitors in series. A kind of connection as shown in the figure is a series connection. It is a one-to-one connection or an end-to-end connection of capacitors. That is, one plate of one capacitor is connected to another plate. Similarly, the second plate of the second capacitor is connected to the first plate of the third capacitor, and so on. Finally, the combination is connected to some source of potential difference V. Now, in this kind of a connection, there is only one path for the charge transfer. That is, there is only one route along which the charges can get transferred. In such a connection, all the capacitors will have the same charge. Here you find that in the figure, each capacitor has a charge Q on its plate. And before we proceed further, let us know what we mean by charge on a capacitor. A capacitor will have two plates, and they will have opposite kind of charges. But what we mean by charge on a capacitor is the magnitude of the charge on any one of the plates. Now, in this case, all the capacitors have the same charge Q. We know that V is equal to Q by C. Now, the capacitances are different. Although the charge is same, we can now expect that the voltages will be different. Let these voltages across the capacitors be V1, V2 and V3. Now, if we add all the three voltages, we will get the applied voltage. Therefore, V is equal to V1 plus V2 plus V3. That is, Q by C is equal to Q by C1 plus Q by C2 plus Q by C3, or 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. That is, in the case of a series connection of capacitors, the reciprocal of the effective capacitance will be equal to the sum of the reciprocals of the individual capacitances.